Hello everyone, my name is Shreya and I am going to shoot a video upon a topic Taylor's theorem. In our engineering maths, there is a topic named application of a partial differentiation. There is a point Taylor's theorem. Here I wrote a formula for Taylor's theorem. So let us understand Taylor's theorem by the example. Now let us see the question. Expand e raised to xy is equal to f of xy in the power of x minus 1 and y minus 1. If we observe, there is a equation given. Also, there is a value of a and b are given. So, let us write it. F of xy is equal to e raised to xy x minus a is equal to x minus 1 y minus b is equal to y minus 1. Here the value of a and b are visible. A is equal to 1 and b is equal to 1. We get it. Now by using the Taylor's theorem, let us replace the value of a and b with 1 and 1. So by Taylor's theorem, okay, here I replaced I replaced the value of a and b by 1 and 1. So now we have to find f of x, f of y, f of double x, f of xy, f of double y, f of triple x, f of xxy, f of xyy and f of triple y. So let us continue. F of xy is equal to e raised to xy. This is a given equation. Replacing x and y by 1 and 1 means the value of x and y putting 1. So we will get e. Similarly, f of x we will get. Now what is f of x? F of x nothing but the differentiate with respect to x. Differentiate f with respect to x means d by dx of e raised to xy. What will get? If we differentiate with x, we will get y e raised to xy. And f of x 1 comma 1 is e by putting 1 and 1. F of xx is equal to, this is a differentiate with df upon dx, means differentiate this equation again with respect to x, means y square e raised to xy. F of xx 1 comma 1 is equal to again e. The value of y is 1 and e is f of triple x is equal to, we can also write it as like this, f of x of double x. Double x we have already find it, that's y square e raised to xy is equal to differentiate with respect to x. So we will get y cube e raised to xy. Now f of triple x, by putting value 1 and 1, we will get again e. Now f of y. Similarly, as we find differentiate f with respect to x, f is dy dy by e raised to xy. Then we will get x into e raised to xy is equal to, now we have to differentiate no, we will get f of y putting 1 into e, f of y. Now f of y with f of y. F of y, we had get x into e raised to xy. Differentiating with respect to y, we will get x square e raised to xy. By putting value of x and y 1, we will get again e. Now the next is f of triple y. F of triple y, we can also write like this. Then f of y, f of double y, we had found it x square e raised to xy. X square e raised to xy. Differentiating again with x cube e raised to xy. F of triple y, putting value of x and y 1, so we will get again e. F of x y means differentiate f of x to the f of y. F of x, now f of y. F of y, we already found it. It's x into e raised to xy. Now differentiate this equation with x. So we have to do u into v rule. In u into v rule, we had seen that if we have to do v as a constant and differentiate with respect to u, and by putting u constant, differentiate with respect to v. Similarly, putting x constant and differentiating with respect to x means here we will get y e raised to xy plus, and putting e raised to xy constant, we will get differentiate dx upon dx get 1. Here e raised to xy are common, so take common part, then we will get xy plus 1. Now f of xy 1 means putting the value of x and y 1 and 1, we will get 2e. How 2e? E raised to 1 into 1 plus 1, it's 2e. We get 2e. F of x xy means differentiate f of x with f of xy. F of x, we find out the equation, this e raised to xy plus 1. Now we have to differentiate with respect to x. So let us continue. Y e raised to xy 2 plus xy we will get by the doing u into v rule. F of x xy 1 1, the value of y is 1, e raised to 1, then 2 plus 1 means 3e. F x y 5. F of x with respect to f y 5. We already found it. F of y. Here f of y is x square e raised to xy. We have to differentiate with x. Then we will get e raised to xy 2x plus x square by the using u into v rule. It's important to use uv rule when you get two variable equations. F of x y y. F of x y y 1 comma 1 is equal to, that the value is e, then 2 plus 1, it is also 3. Now we had get all the values. Now put all the values in Taylor's theorem. F of xy is equal to e raised to xy plus x minus 1 plus here we will get e, y minus 1 e plus 1 by 2. 1 by 2 factorial means 2 into 1 means 2. Then x minus 1 square e plus 2 x minus 1 y minus 1 and 2e, which we had get the value of f of xy plus y minus 1 2e. Sorry, we had get e plus 1 upon 3 factorial means 3 into 2 into 1 means 3 into 2. We will differentiate afterwards. X minus 1 cube e plus 3 x minus 1 square y minus 1, and the value of f of xy is had 3e plus 3x minus 1 y minus 1. The value of f x y y was 3e plus y minus 1 cube e, and the continue. So the final answer is the same, but the difference is 1 upon 6 e raised to xy plus, hence we get the answer of f of xy e raised to xy. Like this, we have to solve all the problems by using Taylor's formula. And the trick for the remembering that is, first let us consider the whole term as a and this whole term as a b. If you consider the whole term as a and b, then this second factorial looks like a plus b bracket square. We know the answer of a plus bracket square, a square plus 2ab plus b square, which we can see they are separated like that. Similarly, a plus b cube is expanded as 3a square b plus 3ab square plus b cube. Similarly, and it can be continued up to n times, but in our syllabus there are only up to 1 upon 3 factorial. So thanks for watching.